Hey everyone, we have a fun project we're going to be working on today, the E-mu Drumulator. So, E-mu Systems, this was their first drum machine that they ever made. This followed the success of the popular emulator at the time. In terms of drum machines, there was not a whole lot of competition out there. There was some that were out that were very expensive, the Lin LM1 being the most famous by far. But it was out of range of most people that wanted the drum machine. It was so expensive. So when this was released, it was released for just under $1,000, which made it very affordable for a lot of people. That combined with its strengths, that is, at the time it was a very powerful, very good sounding drum machine, basically resulted in E-mu selling a ton of them. The Drumulator was also the predecessor to the later E-mu drum machines that became extremely popular and somewhat famous, particularly the SP12 and the SP1200, which came out later after that. So both of those are much more powerful machines than this, a lot more features, a lot more popular, but also a lot more expensive. The Drumulator itself is still affordable to buy today. Working, they go for anywhere from a couple $100 to up to $500 for a really pristine mint one. Broken, they go for even cheaper. So I picked this one up, not working. It actually works. There's some issues, and I will go through what those issues are, and that will be kind of the purpose of this video. We'll take a look at the issues in this and common problems it has and how you fix it, and then we'll also look at the architecture, because this is actually a really interesting machine and really good design. So Dave Rossum was the original designer of this. He was the co-founder of E-mu Systems, and he was basically one of their main hardware guys. He did all the engineering, both the hardware and the software being the actual EEPROM that runs the microprocessor on here himself. And his name is all over the actual service manual for this. Really cool. So there is a lot to discuss about this machine. In this video, we will go through the common problems that it has and how you fix it, how you fix those. We'll take a look at the hardware, do kind of a quick teardown of this, and describe how it works, kind of a theory of operation. We'll look into the samples. So the samples in this are stored on ROM. In this case, EEPROMs, UV erasable EEPROMs, and there's not a lot of sample space. There was 64K total in this device of actual memory. That's 8 bits by 64K. So the samples that come off of this are actually 8-bit samples. PCM, they're in PCM format, unsigned integer, I believe. Well, I'll find that out for sure, because you can, I'll take the data off the EEPROMs and I'll read them. There's some Linux utilities you can use to actually, play that PCM, raw PCM files and actually hear the samples on there. So if we have time, we'll do that in this video too. I don't want this to go on forever. Maybe that may even be a separate video, I'm not sure. Another thing you can do is you can actually write your own ROMs for this and put your own sounds on it, which is kind of cool. So you can, besides the samples that are on there, you can actually put your own 8-bit samples on there. Very short samples, but you can put them on there and replace, the stock sounds. There are actually a couple companies I know of too. One in particular that actually made aftermarket ROMs for this for different sounds, and those were used by quite a few people in their actual production songs as well. So the problems this has are pretty minor. The first thing is the battery's dead. No big deal. Just replace the battery. It's not difficult to do on this drum machine. Second is the buttons. So these buttons are known to go bad over time, and that is the case on mine. A couple of them require quite significant force to actually make them work. So I'll have to go through and replace the buttons. You can buy all these buttons brand new still today, which is nice. They're not terribly expensive either. The potentiometers, they skip a little bit, feel a little scratchy, so I'll see if I can clean those. If not, I'll replace them. Same with the slider. The slider seems to work okay. This is actually used for the data selector for your different values, tempo, etc., stuff like that. And it just feels a little crusty, so I may replace that. Besides that, it needs a good cleaning, and you go through and clean it. We'll take a look at the power supply. It's a really simple linear power supply in this, just a couple capacitors on it, but I may replace those just as preventative maintenance for it anyway. I mean, overall, this machine is generally very reliable. There's not a whole lot that goes wrong with it, and that's due to its simplicity. A quick look at construction. So the whole thing is a plastic case all around. It is a pretty thick, heavy-duty plastic, though, so it's not really fragile by any means. On the back, you've got all your outputs. So you've got outputs for every drum sound on the machine. So there are RCA connectors, which is phone-style connectors, which is kind of odd, but not a big deal. You do have just a standard mono mix out that is a 1/4-inch connector, which is nice. Your gates here are actually external triggers for your drum pads. These are TTL level inputs. You can actually, the drum. There was a 4-part drum pad that was made, 4-pad drum pad that was made for this externally. You could get, and they're pretty rare. You don't really see them, and they do come up very expensive. But you could trigger them by alternate means in there if you so wish to. And then you got a couple other controls on there too for external interfaces and your power switch over there. Now, I will note that I've got a MIDI connector on here. So there was actually aftermarket MIDI modifications you could make to these, and this one has it installed, which is nice. It required an updated firmware for this, version 3.0 I believe, or higher. I believe 3.0 was the latest, to get the MIDI functionality. And there's a couple key presses on the buttons you have to prove or use to make this actually work. But it is a very nice modification. And if you have a Drumulator that does not have it, it's very easy to add. You can buy the kits for not very much money and just install it yourself. Metal plate on the bottom. So looking at this, there are some screws that are missing. So somebody has been in here before, which is not surprising. I mean, the service manual itself, there was lots of modifications and revisions of this hardware that were designed to be made after they originally came out. So mine is serial number 7277. I have no idea where it actually lives in the lifespan of this unit. We'll take a look at some date codes on some chips inside that'll kind of give us a ballpark of when this was actually made, so I know how old this specific model is. On the front, pretty straightforward machine. So you got 4 pads to control your drums. This is a polyphonic machine. You can have, I think, 8 voices of polyphony, even though there's 12 individual sounds on here. Run stop for the actual, play mode on the machine. You got your sound selections here. Well, these buttons serve dual purposes too. And then you got your cassette input for saving and loading to cassette if you wish to save things that way. And then some operations up here for your sequencer. And other just, drum editing parameters. Mix volume, metronome volume. You have individual volumes for every sound too, which is nice. So a lot of the cheaper machines at the time, you couldn't do that, but this one you can. Hence the multiple outputs in the back too. One issue you may see sometimes, and I actually have this, I'll power it up here in a few minutes, but I noticed one of my drums wasn't working. It didn't sound like it was. It might have been one of the toms. I can't remember now. But that's usually caused by the individual volume control for that drum to be turned down all the way. So you got to check to make sure all your volume levels are up for all the drums if you have one that doesn't seem to be making sound. Alright, so here we have the Drumulator hooked up to my bench. I got to power it up here and goes through a self-test sequence and turns on. I've just got the audio going out through a small mixer to my bench speakers here. They don't sound very good, so audio quality is not going to be great here. But, as I mentioned, it does work. So, bass drum, snare, rim shot, cymbal. You actually select drums on this by holding down the drum, the pad right here, and then picking the actual drum that you want to have. So, hand clap, for instance. So, like I said, it works. Some of the buttons, again, require a little bit of force to actually select them. So I'm just going to replace them all anyway. A lot of them are kind of scratched up and dinged up. So that'll be one of the repairs we make here. So next step is we take it apart. So as I mentioned, I know that somebody has been in here recently just because of well, there's only 2 screws holding this thing together. Comes apart pretty simple. So the power supply is actually mounted to this bottom plate. You got the it's a regulator or transistor here, but it's tied directly to the bottom chassis. So use it as a heat sink there. Other than that, it's extremely simple inside. Just classic 80s technology. All TTL 7400 series TTL in there. Main microprocessor is a Zilog's classic Z80. 4 megahertz, I'm not sure, we'll figure it out. Besides that, all the buttons are actually mounted to this board, but they're on the opposite side, on the back side. So you do have to drop this board out to get to the buttons, but it is kind of nice, it's all single board construction. Here's your battery, just your standard 3-volt lithium. I may not just replace that with a board mounted one, I might just put a holder off to the side so I can replace it, instead of having to replace or take the board out to replace it there. You can just get it hot and pull it off from the top, but the proper thing to do is remove the board and desolder it properly if you're gonna go that route. Here is the Midi Modification. This little board sitting over here on the side. You can see the lines that come off. I'll take a closer look at it, but it just taps off some of the logic right here, and then just a small little interface. We'll take a closer look at that to see what chip is on there that makes that work. It's probably just a small little buffer or something, but we'll figure it out. So here are your sample ROMs. These 4 chips right here. They are, these are single time, burnable. They're not the UV erasable EEPROMs, but they are dated 1982 E-mu systems, and they actually are labeled Drumulator, which is kind of interesting. Just a little bit closer look at the board here. So the bottom Drumulator, a little bit glare there. 11/13/82 is the date on the board. Probably not obviously a manufacturing date because it's actually etched into the board itself. So date codes, looking at chips here, we've got 19th week 84, 35th week 84, 31st week 83, 25th week 84, 34th 84. The Dialog's chip, or the CPU, is 42nd week 84, so somewhere late 84, early 85 would be my guess for actual manufacturing date of this unit here. Looking closer at the board here, you can actually see the silkscreen area where they have Drumulator revision to 6583. So that's probably a closer estimation of when this board was actually manufactured versus the actual, etched in the copper date down below of 1982. So closer look at the power supply here. You've got your main lines coming in from the transformer there off the board on this connector here. And here's your voltage selection switch for 115 or 240 for 240 volt mains. And all it's doing is changing the windings on the secondary transformer here. So it's nice that this is actually multi-region convertible if you need to move it from one voltage to another. Besides that, like I mentioned, it's just a really simple linear supply. So you got 4 diodes here that make up your rectifier, big filtering cap there, 2 more over here. 2 small regulators there are looks like 7815, 7915. So that's going to be your plus and minus voltages for some of your analog circuitry and your DAC. And then my guess is over on the metal plate here, you can see just off the side, that's going to be your 5 volt regulator. Everything on here being TTL 7400 series. It's power hungry. This whole board probably draws an amp or more. I wouldn't be surprised. So I almost guaranteed that's just a 7805 there on that chassis. And that's really it for the supply. There's not too much going on there. So in terms of electrolytic capacitors, I mean, there's only 3 right there on the power supply. So these are Nippon Chemicons, 470 microfarad at 50 volt. That's a 4700 microfarad at 16 volt. I don't see a make on it though. But they're all 85C rated. They all been in here since 1984, so I will replace those 3, regardless if they need it or not, because they're old. And that's it for the supply. No, I was wrong. I was right about the regulator, but it's an LM323. That's a 5 volt regulator. A couple amps out of that guy, I think, at least 2, might be 3. So look at the data sheet. But yeah, so that 5 volts powering all of the main board electronics there. And that's why you've got such a big regulator. Alright, so all part. I got a couple little windows here I'm going to clean for the actual LED display. They're just kind of sitting there, not even glued down. You can see how thick this plastic is. I mean, it's almost a 1/4 inch thick. It's just massively strong. So, the plug for the power supply for the transformer here, it's still plugged in. I can't get it off is the problem. I'm putting quite a bit of force on here, and it's actually starting to bend the board, and I don't want to risk cracking anything, so it's not ideal. I'd like to have that unplugged. It makes it easier to work on the board, but it's fine. There's not that much to do on this anyway. So on the front of the board, you can see all those blue buttons that I was talking about. You got the drum pad buttons down here, the start swap switch, your potentiometer, some really nice old school 7-segment displays. These look like old HP, yeah. No, TI, Texas Instrument. TIL312. Those are cool. The older displays always look nice because they have the square segments that don't quite go to the corners like you see on the modern segments where they have the triangle corners, but very cool. Alright, we're going to talk about switches next. So there's 2 switches in the Drumulator. You got the big square one for your 4 pads down here and then your unstop switch. And then you've got your small blue one, which is every other switch in the unit. There's 23 of them that I counted. So this is the more problematic one, for me at least, and this is usually the one that goes bad on these units. So measuring this, we have a switch that is roughly about 12.4, 12.5 millimeters by 12.4. So say 12.4, either direction. And a depth of, at least looking at the plastic portion of it, right around 7.5. So playing on DigiKey's parametric search, I came up with two switches that would basically be good replacements for this. This switch doesn't have, it has kind of a manufacturer logo, but I can't tell what it is. There's a number on there too, and I googled that and it didn't come up with anything useful. So I just went to DigiKey's parametric search and started searching there, and I came up with the two. So the first is a company called C&K, and they have the switch numbered KS11. So the switch is the same pinout, same measurements, it will work. The only downside is that it has this recessed kind of portion of the face of the switch that I don't like because it's not original. It doesn't, you know, this machine doesn't have that. So even though that switch would work in here and you could use it, it's not the one I'm going to use because of that reason. The second switch I found is from a company called E-Switch, and this one is a perfect match. Same exact dimensions, same pinout, it's also blue, and the model of it, or the part number of it, DigiKey part number EG2556. So in quantities of 25, it is $32.90 right now. I think it's just a little bit cheaper if you order the exact amount of 23 you need for this. So not bad. About $32 to get all of the blue switches on here replaced. So the next button I want to talk about is the actual drum pad button, or the trigger button. So this button is a little bit harder to source. I've done quite a bit of searching for these buttons, and I haven't been able to actually locate new ones by any manufacturer of this type. So this button, let's see, I'll give it a measurement here. It is roughly, just the top portion of it, 18.6 millimeters by 18.6, and then it has an overall height, not pushing it down, of just under 11 millimeter. So I've done quite a bit of parametric searches, like I mentioned, with this, and I haven't been able to locate it. So the good news about this button is that it's actually repairable. You can actually pop this apart, clean it, and that will usually revive them. If your button, you know, of this button on your machine is not triggering, or it's double triggering, or intermittent, whatever it might be. So you don't actually have to replace these in most cases. If you do have to replace them, they are expensive. So this button was also used in quite a few drum machines of the era. The Lin LM1 used this exact same button. The Oberheim DMX used this exact same button. The later E-mu SP12 and SP1200s also used the same button. So it had quite a long lifetime, and you know, quite a few machines use it. So you know, you think a lot of stuff would have them, but whenever I find them, people, you know, selling them for sale on you know, eBay, whatever it might be, they want like an enormous amount of money for them, like just price gouging, because you know they're rare. Maybe somebody knows out there, the actual manufacturer. I would love to know what that is, to be able to buy these, you know, at an actual cost of what they should cost. But for this video, we will go ahead and open one of them just so you can see what the process is to clean it. Like I mentioned, I think earlier, these buttons actually work okay for me. They're not sticking, they're not having any issues, but I was going to go through and just replace them if I could anyway, just to show the replacement. But since I can't find them for any reasonable price, I'm going to take this one apart and just show how you would clean it if you have issues with one of them. So you don't actually have to remove this button from the machine either. You don't even need to take the machine apart. Typically you can get into the machine, you know, from the top, and the tops on there kind of fall off really easily. I prefer to take it apart and do it this way though, because then you're guaranteed to be able to get your screwdriver in there to pop it apart without actually damaging it. So what you do is you take a small screwdriver and basically you just kind of pop each side open. Just pry it just a slight little bit, and you'll hear it disengage when it starts to open there. It doesn't take much force. Probably just being a little overly cautious with this one. But when it goes, it'll pop open, and this is what the inside looks like. So there's a small spring inside there that the button actually pushes down on. That's the spring that drives the button. And then the contact actually occurs between this little wire running across and little tiny metal contact. Let's see if I can get better light here. Sitting down side right in there, if you can see it. So those are usually what get corroded or oxidized and need to be cleaned. So you can take a little Q-tips are kind of hard to get in there. So typically what I'll do is I'll either use a dental tool, something like that, or you can use a small knife and kind of get in there and just gently kind of rub, you know, the oxidation. I'll get in frame here on the top. Doesn't take much. If you have some deoxit contact cleaner, you can spray that in there as well. I'm not going to bother on this one. Like I mentioned, the switch is actually working for me. And then kind of rub the top of this on the underside of this wire as well. I keep getting out of frame. And that's it. You can see how there's a little bit more shine on the little tiny contact down in there. And that's usually all it takes. After cleaning it there, you'll get another 10 years or more of life out of this, just depending on your use. And then the button itself, it just snaps back together. And you're usually good to go. So I'll go ahead and I'm just going to clean the other 4 in here, just because I'm here, and why not? And that's it. We just need to wait a few days for my parts order to come in for the blue buttons to replace. You can clean these too, by the way. These actually pop apart, but they're so inexpensive. I usually just go the replacement route with them. The top will just kind of pop out on them. Oops. There's a metal contact that sits in there, and that's what provides your detent to make the button snap. And then this connector here, this little pad, again, focus, here, you would clean this. In here you got easier way of getting a Q-tip in there and actually wiping that a little bit better clean. And then the other metal contact sits right over here. And you can see the same thing, how black it is. So if you were just to scrape that a little bit, get that oxidation off there, you can get it clean, and usually that will resolve the switch. And you set the little spring, take a look at the back. There's not a lot of... Normally I'd wipe this clean, get my fingerprints off of it too, but I'm not reusing these, so I'm not going to bother. Throw the pad back in and snap the top back on, and that will usually bring those back to life. So that was quick and easy, so I'm glad I showed that. Anyway, parts are on its way, so once the parts arrive, I will replace the blue buttons, do the caps. I'm going to clean the slider and the pots, and that's really it with this. We'll reassemble it and try it out. Alright, it's been a few days. I've got my DigiKey order in, so all the parts are in that I ordered. I've got some extra stuff in here I ordered too for some other projects, but I'm only interested in a few things for this, which are... Here's our switches. I'll have to go through the caps. A couple of these caps are for this unit. And then the battery too, which I'll actually talk about the battery here in a few minutes. You always have to ship any size lithium, you have to ship ground now. So I had these delivered FedEx ground, which usually still gets here pretty quick. Anyway, we will begin with the switches. So the new switches compared to the old ones, you can see that they are basically an identical match, which is pretty cool. So pinouts perfect. So these are the right switches to use. Now, a note with the switches too is I ordered all blue ones to keep it, original factory look. But what some people I know have done is they replace some of the buttons with white and red to kind of make it look like the SP1200, which is kind of neat. So you have the option to do that if you wish. For me, I'm just keeping them blue though. So I will begin. I've got all the old ones out, so I'll begin replacing it and soldering them in. Okay, all the buttons are now replaced in this. I've got 2 spare, because I ordered the 25 and I only needed 23. I just wanted the spares in case something went wrong and I needed one, but they're good there. I reinserted the run stop switch, one of the drum pads down here on the bottom, the trigger pads, and I cleaned out the remaining 4 along with the one that I had removed. So buttons are good at this point. Next step is the capacitors. I mentioned I wanted to replace those. So they are working, the power supply is working on here, but again it's old and there's only 3 of them. And I like to replace capacitors on all this old gear just because they will begin leaking at some point, just based on their age. So the capacitors I'm going to be using are Panasonic's, 105C rated. This is the FC series of electrolytics by Panasonic. Really high quality caps. I use these in all my repairs basically. So I've got the 4700 at 16 volt to replace him, and then I've got 2 470 at 50 volts for the 2 that are here. So I will replace those really quick, and then we will take a look at the battery and clean the pots and we'll be done. Okay, capacitors replaced. Next, look at the battery. And I got a couple new ones, basically identical replacements. They are little 3 volt lithiums. Packaging. So, Panasonic branded with the solder tabs on there. So this specific one isn't board mounted like the one on there with the actual pin leads, but you can still just, you know, either make your own lead, solder them on here to put it in the board, or leave the leads on there cut enough to replace it. But what I was going to mention earlier, it's actually measuring this battery. It's still good. So we've got, you know, 3.1 volts on this cell. So this has been replaced before. And I confirmed that when I looked at the bottom because the solder pads in there were obviously fresh. So some point in the last 10, 15 years, I don't know, this has been replaced. So I'm not going to bother replacing it this time. It's easy to replace, it's easy to get to. So I'm not going to do it. But that really concludes the repair for the buttons here. What I want to do is reassemble this back together and then verify that, you know, everything is working as it should. There still could potentially be other problems on this besides the buttons. Again, some just weren't responding. It's usually always the buttons, but we won't know until I have it back together and we test it out. The only other thing I wanted to do was clean the fader on here. Like I mentioned, it was feeling a little rough on there. So to do that, I'm going to use deoxit. I'm going to use the deoxit design for carbon pads, which I have over here. It's by Kaga Industries, the MCL, the moving contact lubricant. So as it says, it's designed for carbon-based controls. So it's better than the deoxit, which I accidentally mentioned before, for switches and conductors. This stuff is better for potentiometers, sliders, stuff like that. It lubricates it and gives it a nice feel. So I will clean that real quick. So I know you can't see this, but I'm just spraying a little bit in that fader. Working around. Alright, so the cover of the Drumulator, while I have this apart, this would be a good opportunity to clean it when all the buttons are removed from there, so you can just kind of wipe the whole thing down. So I'm going to do that really quick with my plastic cleaner, which I have over here. I'm not going to spray it on my bench because I don't want to get it all over the board there, but I will do this off camera real quick. And here it is after wiping it down. So looks a lot better. There's a couple scratches in here that are pretty deep that aren't going to come out, but for the most part it cleaned up pretty nice. So you see how dirty the rag was from wiping it down. It's pretty gross. But anyway, now I will reassemble so we can test. So here is the Drumulator reassembled. We will power it up. Everything looks good at this point. So I cleaned the 2 lenses too. There's these 2 little red pieces of plastic for the 7-segment displays that were a little nasty. I cleaned them. They still have some surface scratches, I would like to replace those at some point, but they look much better than they did. The material is just like a red thin film, almost like a gel for a studio light. So it'll probably be pretty easy to replace with something similar to that. But that aside, we shall see if it works. I'll plug the audio in. And so pads work, which is good. Built-in sequencer's working. Let's test all the sounds. So all the toms. You notice my tom is back too. I was having trouble with that one earlier, but I didn't have sound on it. So none percussion. So everything looks good there. I'll go through and I'll actually have to test every button. I mean, depending on the mode you're in, some of these will do stuff. Other times they won't. But I mean, so far it looks like everything's working, which is good. So. Tempo, what mode am I in now? There we go. Tempo, 40 to 240. So, yeah. The slider's still not feeling as nice as I would like it to. It's still a little rough. It works though. There's no gaps or anything. It's very linear in terms of the movement of the encoder. It's essentially a digital encoder at this point, analog to digital encoder that is, so it seems fine. Both the mix volume and metronome volume work, which is good. There's no scratchiness with them. The metronome, obviously. Actually, that one is a little scratchy. I'll have to clean that one a little bit better. But anyway, we're good, so I'm happy with this. This guy is working now, which is awesome. So last couple little things, I want to take a look inside. I promised that earlier in the video. Just because this is running a little long, I'm probably not going to get into the actual ROM writing in this video. I think I'm going to make a separate video that talks about that in terms of how to get your own sounds on this, if you wish to do so. It's actually pretty easy to do. So I'll save that for a different one, but I do want to look inside real quick and just kind of go over a little bit more of the digital logic that's going on inside this guy. Okay, so inside the E-mu Drumulator, we'll start with the CPU area over here on the right. So we've got a classic Z80. This is running basically the entire machine. So these are pretty common, pretty much of everything from the 80s, because they were a very cheap microprocessor that was very easy to integrate into designs. Down here on the bottom, you've got some ROM, and RAM for that matter. So this ROM here is actually your system ROM. As I mentioned earlier, this has got version 3.0 on it. You have to have version 3.0 for the Midi modification to work. So this would have been upgraded later when the Mini mod was installed. These two chips down here are your RAM. These are RDA CDM 6116. These are 2K by 8-bit RAM chips. Essentially, they're static RAM. So that's obviously required for operation of the Z80 there. Moving along over here, we have our clock generation circuitry. There's a 5 megahertz crystal running this unit. There's probably some additional glue logic in here and timing logic, driving a couple different clocks off of here to drive everything else on the board. Being SRAM, it's nice because the timings of these are super simple. You don't have near the timing complexity like you do with DRAM. These basically just run at system clock. So the ROM, these are the 4 Drumulator ROMs over here. So these are single, one-time programmable ROMs. So as I mentioned before, the samples on here are 8-bit unsigned integers in a PCM format. The sample rate I don't know offhand. I was hoping to figure that out in this video. I probably won't now. I'll save that for a future video when I talk about putting your own sounds on here. But these were basically, the source of all the sound on here. The way that they stacked the sounds on was good too. If you've seen my TR-505, Roland TR-505 video, I kind of talked about, something similar there, that they actually stack different sounds, at different addresses within here. But for the crash cymbal, because it's such a long sample, they actually have one ROM dedicated strictly to just the crash cymbal. All the other drum sounds are, broken up between the different ROM chips there. So the sounds themselves that come off of, the ROMs here to be converted to analog actually go through this DAC right here. This is an Intercell part number, 807523. This is an 8-bit DAC, which makes sense because it's an 8-bit machine in terms of the actual audio quality. So things get really interesting as the data is converted through this DAC, though. First of all, there is a level option on here in terms of, you know, the actual audio output for every sample that's being played through, and that's controlled down by this section here, because there's a second DAC. It's not really a DAC, but it is a output basically in this area here, including this chip, which is a programmable RAM that multiplies the sound data coming off of here as it's hitting the DAC to give you the proper level going off to the analog circuitry. So, as I mentioned earlier in the video, it has 8 voices of polyphony, and the way that it works is that the sounds coming off this DAC are actually multiplexed. So this circuitry right here is that multiplexing circuitry. This first chip, which is labeled DMX88, is a 8-channel demultiplexer. The way this works is that when you're playing multiple sounds at once, the actual microprocessor is time slicing the output of the sound waveforms, the sound waveform data from the ROMs, converting it, you know, from digital to analog at that point, and then demultiplexing it into different actual sample and hold circuits. And that's what this little area is here, made up of these EPROMs. So the reason it does this is because you have all the actual individual outs on this unit for individual sounds. So the sample and hold circuit here made up of these op amps and all these capacitors. These capacitors will store the current voltage level coming off of the digital analog converter for each output, and then redirect it through filtering through that actual output. Now each of these actual channels too goes through filtering, because there is multiple filters on here for the different sounds that are being generated. So a couple of the sounds on here, specifically the hi-hats and the ride cymbal, go unfiltered. The reason because is that they want as much high frequency energy as possible to actually get out to the outputs, you know, in terms of making the sound realistic. The remainder of the sounds now, or at least most of the remainder of the sounds, go through simple analog filters made up in this section over here of just, you know, your simple RC type filters. Those cut a little bit of the high frequency energy, things like your clap and your rim shot and things like that. Finally, there's 2 filters specifically for the toms on this unit, and they're made up of these chips right here, the SSM2044. So these 2 filters are pretty famous chips. They were used in the PPG Wave. They're also used in the Korg Poly 6, among numerous other synthesizers out there. The cutoff and resonance that you can get out of these filters is really, really good. And they're used in the Drumulator specifically for the toms, because you need that certain attack and decay for those drum sounds to sound correctly. So it's cool that they have 2 of them in here dedicated for those sounds. One funny thing I just noticed as I was cleaning up these knobs, on this one, the white line lines up on the top to the bottom there, which it should. On this knob, it doesn't. It's very strange. I don't know why. It's like they misprinted it wrong. And it's not like any of these pieces rotate either. It's a solid piece. So I thought that was kind of funny. I didn't notice it until now. Well, makes this one unique, I guess. So this will conclude the simple repair of the E-mu Drumulator. Again, nothing drastic here, just button replacement and some preventative maintenance, but kind of cool. Went through the machine a little bit. I plan on going through this a lot more in a lot more detail in some upcoming videos, so if you're interested in that, let me know, and I'll kind of prioritize making those videos for this. So hopefully this is beneficial for you. This is a very cool machine. I'm glad I finally got my hands on one. I would recommend getting one now if you want to, because I can only imagine them going up in value at some point, like everything else, you know, from this era is. Like I mentioned before, you can still get these pretty cheap. Working ones definitely under $400. Ideally around $200 to $300 was what you would pay for a working one. Non-working or one with issues like this one has, is you can get them for significantly less than that. So keep watch for them, and thank you for watching.